Come on, everybody. You are on the channel for English for Biology majors, which is brought to you by Tsinghua University's Susan Ye. We hope after you learn this class, you will think biology is fun and to read biology book is piece of cake. Let's go, yay! Hello, everyone. Today we will continue to learn prefix and suffix that's related to chemistry. But first, we still need to review what we learned last time. For chemistry, we have three prefixes: chemo, C-H-E-M-O, chemi, C-H-E-M-I, and chemical, C-H-E-M-I-C-O. For sulfur, the element sulfur, we have one prefix, thio, T-H-I-O. For divalent sulfur, we have one prefix, sulfo, S-U-L-F-O. And for calcium, we have two prefixes, calco, C-A-L-C-O, and calci, C-A-L-C-I. For carbon, we have two prefixes, anthraco, A-N-T-H-R-A-C-O. This one can also be used on charcoal. And then carbo, C-A-R-B-O. For carbon dioxide, we have one prefix, capno, C-A-P-N-O. And for coal, and we use one prefix, anthraco, A-N-T-H-R-A-C-O. For hydrogen, we have one prefix, hydro, H-Y-D-R-O. For oxygen, we have two prefixes, O-X and oxy, O-X-Y. Now let's continue to lesson 17, the second part of it. Still, we are going to learn some prefix and suffix that's related to chemistry. For iodine, I-O-D-I-N-E, we have one prefix, I-O-D-O, aldo. Let's see our example. Aldotherapy. Aldotherapy is a treatment usually for a goiter, like this woman, with iodine or iodides as medicine. For iron, we have three prefixes, ferro, F-E-R-R-O, ferri, F-E-R-R-I, and sidro, S-I-D-E-R-O. Let's see our example. For ferro, our example is ferroprotein. Ferroprotein is any protein that contains an iron in a prosthetic group. Like in this picture, we show this protein is a cytochrome C, which is a component of oxidative phosphorylation. And the cytochrome C has an iron in the center, so it is a ferroprotein. Our example for ferri, F-E-R-R-I, is ferric chloride. As shown in the picture here, this is a ferric chloride hexahydrate. Ferric chloride is an industrial scale commodity chemical compound. And for sidro, S-I-D-E-R-O, our example is sidrocyte. Sidrocyte is an abnormal red blood cell that has iron granules that are not part of the hemoglobin. In this picture, we show is normal red blood cell because we can't find the sidrocyte. Let's review what we've learned for iron. We have three prefixes, ferro, F-E-R-R-O, ferri, F-E-R-R-I, and sidro, S-I-D-E-R-O. For chlorine, which is a gaseous element, we have one prefix, chloro, CHLORO. Our example is chlorobutanol. Chlorobutanol, the structure of chlorobutanol is shown here. It is a chemical preservative, sedative, and it's hypnotic, and it can be used as a weak local anesthetic, similar in nature to chlorohydrate. And we have more example for chloro. Another example is hypochlorous acid. Hypochlorous acid, as shown in this picture, is a weak, unstable acid, known only in solution. It is made by the action of chlorine on water and, along with its salt, the hypochlorites. It is used as a household bleach and also the disinfectant in swimming pool. We usually coined as the chlorine in the swimming pool. Actually, it is hydrochloric acid. In a pool, chlorine's job is to kill bacteria. It does not take care of bodily functions. Why do I say that? Because in a survey done by the CDC of America, they found that 1 in 6 people has done the unthinkable things, pee in the pool. And they thought the hypochlorous acid will take care of their pee, but actually the job of chlorine is to kill bacteria. It does not take care of bodily functions. So if we pee in a pool, hypochlorous acid readily reacts with the uric acid in our urine. Resulting compounds are cyanogen chloride, CnCl, and the trichloramine, and these two are potentially hazardous. Scientists have found that frequent exposure to trichloramine and cyanogen chloride in the pool will raise the likelihood of asthma and other respiratory problems. Although these still remains more study, but we shouldn't pee in a pool no matter what. And okay, it is the cyanogen chloride and the trichloramine. And one more example, hydrochloric acid. Hydrochloric acid, which is commonly used in the lab, it is a strong acid made by dissolving the gas hydrogen chloride in water. It reacts with alkalines, bases, and many metals to form chlorides. It has many industrial applications, but it's a strong acid, so it is dangerous. When you are using it, be careful. For water, we have one prefix, hydro, H-Y-D-R-O, which is the same as hydrogen. Remember the first part of the lesson 17. Let's see our example for hydro in water. Hydrolase. Hydrolase, in biochemistry, it means an enzyme that catalyzes the hydrolysis of a substrate. Like in this picture, a hydrolase hydrolyzes this compound and generates 2 compounds. And this enzyme is a hydrolase. Now the suffix ase, remember we learned that before, it means an enzyme. For bromide, we have one prefix, bromo, B-R-O-M-O. Our example for bromo is bromophenol blue. Bromophenol blue is an acid-base indicator, and it can use as a color maker and a dye. In the lab, bromophenol blue is also used as a color marker to monitor the progress of agarose gel electrophoresis and the polyacrylamide gel electrophoresis. And the reason why it can be used for agarose gel electrophoresis as a marker, as we show in this picture, is because bromophenol blue carry a slight negative charge at moderate pH, so it will migrate in the same direction as DNA or protein in a gel. The rate at which it migrates varies according to gel density and the buffer composition, but in a typical 1% agarose gel in a one-fold TAE buffer or TBE buffer, bromophenol blue migrates at the same rate as a DNA fragment, about 300 base pairs. And in a 2% agarose gel, it migrates as 150 base pairs. Bromophenol blue is the middle dye in this agarose gel, and the lighter blue one is the xylene cyanol. Xylene cyanol is also used in an agarose gel electrophoresis. Next, we are going to learn thallium. Thallium, the symbol is Tl. Thallium is a metal, and the prefix for it is thallo. Thallo. Our example for thallo is cellotoxicosis. Cellotoxicosis is thallium poisoning. When one person injects thallium by accident, or maybe others try to poison them, then they will suffer from cellotoxicosis. And actually, because thallium, when it dissolves in water, it doesn't have a taste. So it was once an effective murder weapon before its effect became understood, and an antidote. The antidote for cellotoxicosis is Prussian blue. After Prussian blue was found to be an effective antidote for thallium poisoning, then thallium is not being used as frequent as it was. Thallium poisoning, because as I said, it doesn't have a taste, so it has been called a prisoner's poison because it's colorless, odorless, and tasteless. It doesn't have a taste, and it's slow-acting, painful, and the wide-ranging symptoms are often suggestive of a host of other illness and conditions. So it's very difficult to diagnose a thallotoxicosis. And the last one in this part of lesson 17, for electricity, there's one prefix, electro, E-L-E-C-T-R-O. Our example is electrocardiogram. Electrocardiogram is the visual output that an electrocardiograph produces. It's a graphic tracing, as we show in our PowerPoint, of the variations in electric potential caused by the excitation of the heart muscle and detected at the body surface. So when we do electrocardiogram, the doctor will attach those electrodes on our body. Then it will detect the variations in electropotential caused by the excitation of the heart muscle, and then record it as we show in this PowerPoint. Then This is called an electrocardiogram. And the machine is called an electrocardiogram. Now we finish this part of lesson 17. Let's review what we learned today. For iodine, there's one prefix, ido, I-O-D-O. For iron, we have three prefixes, ferro, F-E-R-R-O, ferri, F-E-R-R-I, and sidero, S-I-D-E-R-O. For chlorine, there's one prefix, chloro, C-H-L-O-R-O. For water, there's one prefix, hydro, H-Y-D-R-O. For bromide, there's also one prefix, bromo, B-R-O-M-O. And then for thallium, T-H-A-L-L-I-U-M, thallium, we have one prefix, thallo, T-H-A-L-L-O. This prefix can also use to describe the shoot, the shoot of plants, because the first time thallium was found, the scientists they burn the metal on the fire and see very bright green flame. So actually they borrow this prefix thallo to use on thallium. And then for electricity, there's one prefix, electro, E-L-E-C-T-R-O. Now we finish the second part of lesson 17. Next time when we come back, we'll continue to learn more prefixes and suffixes for chemistry. See ya! English for Biology Major is brought to you by TCU's English for Biology Major course team. If you have any questions, don't forget to visit our FB fans page. The website is here, and you can also scan the QR code to reach to our FB fans page. This course is sponsored by Centers for Faculty Development and Instructional Resources of TCU.